Hello everyone, welcome to my YouTube channel. Today I'll conducting the topic from Engineering Mathematics 3. The topic from the unit Fourier Transform. From this unit we will see the topic Fourier Sine Transform and Fourier Cosine Transform. First we see Fourier Cosine Transform. Here, Fourier cosine transform is denoted by fc of lambda, and which is defined as if the function f of x is defined on the interval from 0 to infinity, then the Fourier cosine transform is given by the formula fc of lambda is equal to integral from 0 to infinity f of u cos lambda u du. Remember this, if we find the Fourier sine or cosine transform, always we take the limits from 0 to infinity. Always we write the function f of x is in terms of the variable u. We write f of u. If we find the Fourier cosine transform, then here we write cos lambda u and we find the integration with respect to u. Now we find inverse Fourier transform. For finding inverse Fourier cosine transform, we find f of x. We find the inverse, that is we find the f of x. This is equal to 2 upon pi integral from 0 to infinity fc of lambda cos lambda x d lambda. Here this fc of lambda is the Fourier cosine transform which is the given. We take cos of lambda x because the given value is of Fourier cosine transform, and we find the integration with respect to lambda, and always we multiplying for this inverse Fourier cosine transform or sine transform, multiplying by 2 upon pi. Therefore we got inverse Fourier cosine transform is f of x is equal to 2 upon pi integral from 0 to infinity fc of lambda cos lambda x into d lambda. Similarly, we find Fourier sine transform which is denoted by fs of lambda. We find the value of Fourier sine transform of the function f of x if the function defined in the interval 0 to infinity, then this given by fs of lambda is equal to integral 0 to infinity f of u sine lambda u du. If Fourier sine transform, then always in the integration sine lambda u. Put the value of function f of x as f of u and find the integration with respect to u. Now we find the inverse Fourier sine transform, that is we find the value of function f of x which is equal to 2 upon pi integral from 0 to infinity fs of lambda sine lambda x d lambda. These are the symmetric forms for Fourier sine and cosine transform. Generally we use these first two formulae to solve the examples. These are also useful. Now we see the example of Fourier sine and cosine transform. We see the first example. In first example, here we find Fourier cosine transform of the function f of x, where the f of x is the value of function f of x is equal to x in between 0 to half, 1 minus x in half to 1, and 0 if x is greater than 1. That is the given function f of x is defined in the interval 0 to infinity, and the 0 to infinity split into three parts: 0 to half, half to 1, and 1 to infinity. Therefore, we find Fourier cosine transform. We use the Fourier cosine transform formula. The formula is, we know, Formula for this: fc of lambda is equal to integral from 0 to infinity f of u cos lambda u d. Now the given function is in three parts, therefore we split this integral from 0 to infinity as 0 to half, half to 1, and next is the 1 to infinity. But in between 1 to infinity, the value of function is 0. Therefore, we consider only from 0 to half and half to infinity. If the value in between 0 to half, then value of function is x. We put this value in terms of u into cos lambda u du. And if the value in between half to 1, then value of function is 1 minus u. 1 minus x. We put in terms of u, then we got 1 minus u into cos lambda u du. Now we find the value of integration of both the integral. Here the value of first integration, we find this by using integration by parts. All of you know the formula for integration by parts. Here we find integration of uv, that is, here we find this is by using, if here u is a polynomial and v is any function, then we find the integration by using the formula. First we take u constant into integration of v minus we take derivative of u into the double integration of v. In this way we find the values. Here first is u constant integration of v minus derivative of u into double integration of v. If we take the next term, then this is the positive term, and here value of next term is double derivative of u into triple integration of v, same as the chain rule. Here we find this value by using the formula. Here first we take u constant, that is, here we take the u constant, and integration of this cos lambda u is sin lambda u upon lambda, plus we take the derivative of u is 1 into the double integration of cos lambda u is we take the integration of the sin lambda u upon lambda. Here this sin lambda u upon lambda is the first integration. Here double integration of this is cos lambda u upon lambda square. Put the limits from 0 to half. Similarly, we find the value of second integration. We find the value of this second integration. For this, first again use the same formula. First we take 1 minus u as constant, and we take the integration of cos lambda u. Integration of cos lambda u is again sin lambda u upon lambda, minus we take the derivative of this 1 minus u. Derivative of 1 minus u is minus 1 into the integration of double integration of cos lambda u is minus cos lambda u upon lambda square. Put the limits from half to 1. If we put the limits from half to 1, then we got in next step. In next step is first we put the value in the first integration. Then we got the term here u into sin lambda u upon lambda plus cos lambda u upon lambda square. If we put the upper limit half, then we got the term u is half, therefore we got term is half. Here u is equal to half, therefore we got half into sin lambda by 2 upon lambda, plus here the term is cos lambda by 2 upon lambda square. And if we put the lower limit 0, then we got first term is equal to 0, and the second term is cos 0 is 1 upon lambda square. That is, if we put lower limit, we got the minus sign, therefore we got here minus 1 upon lambda square. Similarly, we find the value by using this second term. Put the upper limit 1. Here we got 1 minus 1 is 0, therefore first term is 0. Put here 1, then we got cos of lambda. Therefore, we got the next term cos lambda upon lambda square minus 1 half into sin lambda by 2 upon lambda plus cos lambda by 2 upon lambda square by using this lower limit half. Now simplify all these terms. We got the value of Fourier cosine transform. The value of Fourier cosine transform is minus into cos lambda plus 1 minus 2 cos lambda by 2 upon lambda square. In this way, we find the value of Fourier cosine transform. Similarly, find the Fourier sine transform. Here in next example, find the Fourier sine and cosine transform of the function f of x. Here again we split this into the three parts. The interval 0 to infinity is split as 0 to 1, 1 to half and x is greater than 2, that is 2 to infinity. We use the same procedure to find the value. We see how to find the Fourier sine transform. Here we find Fourier sine transform. For this we use the formula of Fourier sine transform. Here Fourier sine transform is fs of lambda is equal to integral from 0 to infinity f of u sine lambda u du. Now we split this 0 to infinity as 0 to 1, 1 to 2 and 2 to infinity. Therefore we write this 0 to 1, then the value of function is u. If we take 1 to 2, then value of function is 2 minus u. And if we take 2 to infinity, then the value of function is 0. Now we find the value of integration of the function by using the same integration formula, that is integration of uv is equal to the u into integration of v minus derivative of u into double integration of v. We find this. Here first we take u constant into the integration of sine lambda u is minus cos lambda u upon lambda. Then we take minus sign into the derivative of u into the double integration of sine lambda u. Derivative of u is 1 and the double integration is minus sine lambda u upon lambda square. And we put the limits from 0 to 1. Similarly, we find the value of second integral. Second integral term is 2 minus u sine lambda u du. Again use here u into v rule. First we take u constant, that is here take 2 minus u is constant into the integration of sine lambda u. Integration of sine lambda u is minus cos lambda u upon lambda minus we take the derivative of 2 minus u. Derivative of 2 minus u is minus 1 into the double integration is minus sine lambda u upon lambda square. Put the limits from 1 to 2. If we put the limits, then here we got the value minus cos lambda, that is if here we put the value if here we put the limits from 0 to 1 in this term, then we got, if we put the upper limit, then we got here 1 into cos lambda upon lambda. Therefore we got the term minus cos lambda upon lambda. If we put in second term 1, then we got minus minus plus sine lambda upon lambda square. Then put the lower limit 0. If we put the lower limit 0 in this term, we got 0 into term is 0 and here sine 0 is 0. Therefore both terms are is equal to 0. Now we take the second. In second put the upper limit 2. If we take 2 minus 2, then we got 0. Therefore this first term is equal to 0. Now in second term we put u is equal to 2. If we put u is equal to 2, then we got the term minus sine 2 lambda upon lambda square. Now we put the lower limit 1. If we put the lower limit 1, then here we got the term 2 minus 1 is 1 into minus cos lambda upon lambda. That is, we got the term cos lambda upon lambda and put the 1 in the last term. Then we got cos lambda upon lambda square, sin lambda upon lambda square. Now collect all these terms. We got the value of Fourier sine transform. Here same terms plus minus sign terms get cancelled. That is, here the term minus cos lambda upon lambda cancel with this cos lambda upon lambda. Also the term is here sin lambda upon lambda square and sin lambda upon lambda square, both having positive sign. Therefore we got here 2 into sin lambda, and here this term is as it is minus sin lambda upon lambda square. Therefore we got the term 2 sin lambda minus sin 2 lambda upon lambda square. Now simplify this term. We got the value 2 sin lambda minus value of sin 2 lambda is 2 sin lambda into cos lambda upon lambda square. Now collect the terms. We got the value fs of lambda is equal to 2 into sin lambda in bracket 1 minus cos lambda upon lambda square. In this way, we got the Fourier sine transform. Similarly, try to find the Fourier cosine transform of the function. Thank you. Thank you for watching the YouTube channel.